You know the periodic table, right? That chart from the wall of every science classroom. But what if I told you it's not just a chart? What if it's a blueprint, a deep mathematical code that literally dictates the structure of our universe? Well, today, we're going to unlock that code.
For the longest time, we treated the elements like a stamp collection. An impressive but kind of random assortment of things we found. But it turns out there's absolutely nothing random about it. The way matter is arranged follows a precise, predictable, and, get this, even a calculable pattern.
So that begs the real question here, doesn't it? Is all this incredible order just some massive cosmic coincidence? Or could there be a master key, a single elegant formula that just explains the whole shebang? Let's find out. Okay, so if there really is a blueprint, what does it look like? Let's dive into our first section here and reveal the single equation that seems to govern the entire periodic table. All right, here it is, the master key. This is the generic equation of Mendeleev, and its real power is just how deceivingly simple it looks. With just these few parts, we can predict the exact number of elements in any row of the table, even rows for elements we haven't even discovered yet. Let's just break it down real quick. P is simple. It's just the row number you're looking at. The int operator just means ignore the decimals. And C of P? Well, that's your answer, the number of elements in that row. Seriously, that's all there is to it. But the real beauty of this equation isn't just what it does, it's how it does it. Its power comes from this really fascinating dance between two opposite forces: perfect, clean symmetry and just a little bit of calculated chaos. Think of it like this. On one hand, the number 2 gives us this perfectly balanced, symmetrical foundation. But let's be real, a universe that's only symmetrical would be, well, pretty boring and static. So the equation also introduces this crucial piece of asymmetry, and that's what allows for all the rich complexity we see in the world around us. Now, what's so wild here is the role of the number 2. It's like the symmetrical backbone for the whole system. I mean, look at it. It's used to multiply, to divide, it's added, and it's used as a square power. This number is literally the key to the pattern's perfect balance. But a purely symmetrical universe would be predictable and kind of sterile. To get real complexity, nature needs to break that perfection just a little. And that's what the int operator does. It takes a smooth, continuous flow and chops it up into distinct, separate steps. Think of it like walking up a staircase instead of just rolling up a ramp. This creates the quantum jumps that give rise to the incredible variety in our world. So, we have this really beautiful theory, but the big question is, does it actually hold up in the real world? In this next section, we're going to put the blueprint to the test and see how this abstract math actually creates a stunning physical form. And here it is. This is where the theory smacks right into reality. When we plug in the numbers for the periods we already know about, the equation doesn't just get close, it nails it. 2, 8, 18, 32. A perfect prediction every single time. This isn't just a good guess, it is a perfect match. But it gets even cooler. The equation's power goes way beyond just spitting out numbers. This mathematical logic actually projects into the real world, creating these incredible three-dimensional geometric structures. These aren't just pretty pictures. They're models that show how atoms might arrange themselves in space, forming what scientists have started calling spatial crystals. And two main models seem to emerge from this math. First, you've got the X structure, which is just beautiful at showing the double symmetry of its growth. Then there's the K structure, which is a bit more realistic. It blends that 3D form with the traditional columns we're used to seeing, showing us exactly how new orbitals get added to the mix. Here we can see the two models right next to each other. Now, they're a little different in their geometry and how they grow, but they both give us a unique window into the underlying architecture of the elements. And check out the anchor points. Both models are grounded in the same fundamental elements. It's like a beautiful geometric harmony. So the math works and it creates these incredible structures. But now we're going to peel back one more layer. And this is where we find the most profound connection of all: the link between this simple formula and the wonderfully strange world of quantum physics. You see, this isn't just some neat mathematical trick. The equation is a direct reflection of the laws of quantum mechanics. Its structure is dictated by the exact same rules that tell electrons how to behave. And electrons are the particles that define what makes every element unique. Now,
When we simplify the equation, something truly amazing happens. The fingerprints of two super important quantum numbers, n and m, they just appear. This is the smoking gun. This is the proof that the entire structure of the periodic table is a direct result of the quantum world. It's literally quantum physics, just written in the language of math.
Okay, so we have a blueprint. It's been tested, it's been validated, and it's grounded in the fundamental laws of physics. So what's next? Well, now we do something really exciting. We use it to venture into the unknown and predict the future of matter itself.
And the pattern just keeps going. The formula predicts that the next two rows, periods 8 and 9, will each contain a whopping 50 elements. And it doesn't stop there. It predicts periods 10 and 11 will have 72 elements apiece. The blueprint just continues to unfold in these perfect symmetrical pairs. We can even push this thing to its absolute limits and take a journey way out into the distant future. The formula predicts a hypothetical period 16, a realm of matter that's way beyond anything we've ever seen. And it tells us with mathematical certainty that this period will hold exactly 162 elements.
So what does this all mean? It means the periodic table isn't just a list of ingredients. It's the recipe for the universe, written in numbers. The growth of the elements is this beautiful dance between the perfect symmetry of the number 2 and those quirky quantum leaps of the equation. This quote just nails it. Think about what it's really saying. Our universe isn't some random mess of particles. It's a cosmos built on a deep, elegant, and, most importantly, an understandable mathematical order. And that brings us to our final and maybe most exciting question. If the very building blocks of matter follow a hidden blueprint, what other cosmic codes are out there, hiding in plain sight, just waiting for us to crack them? The universe is full of secrets, and it feels like we've only just started to read the instructions.